Hello, it's Mr. Bush here with basically how to do today's homework. Before we get started on the homework, I'm going to remind y'all how to basically use coefficients and subscripts to determine how many atoms are in a particular compound. So let's go ahead and start with today's example. If you look right here, this subscript means that you have 2 hydrogens, and this one means you have 3 oxygens, and no number means you only have 1 phosphorus in that particular molecule, which means every group of those will have 2 hydrogens, 1 phosphorus, 3 oxygens. Alright, now let's go ahead and look at what our coefficient means. Our coefficient there means that you basically have 2 groups of that molecule, which means you basically have 2 different molecules of that compound. So, the way you figure out the number of atoms is you simply multiply the coefficient by the subscript. So if you look here, if you multiply our 2 by the subscript of 2, you get a total of 4 hydrogens. So you would have 4 hydrogens. If you multiply our 2 by the 1, because remember, no number means 1, you would have basically 2 phosphorus. And if you multiply the 2 by the 3 there with the oxygen, you would get 6 oxygens. And that's how you count basically the number of atoms from each element with a particular molecule. Alright, let's go ahead and look at how we balance our equation. Alright, the very first step on every single problem is to identify your products and your reactants. Now, if y'all remember, the products, well, actually let's start with the reactants. The reactants are what you start with. Basically, they're going to be on the left side, or the first thing that you see. These are the 2 elements or the 2 compounds that are going to react together and make something. The things that you produce are going to be called products. They're going to be on the right side of that arrow. It's basically what you make. Now, it's the same exact atoms throughout the entire reaction. They're just being rearranged into new compounds. So, during a chemical reaction, you don't make or produce any atoms, you just rearrange them. And they follow the set ratio of our chemical formulas there. So they have to follow this ratio, kind of like a cake recipe, if you will. So, let's go ahead and look to see if these are going to be balanced or unbalanced. Now, the first step is you need to write down the number of atoms in your reactants. So let's go ahead and do that real quick. Alright, so if you look here, the reason why you have 2 hydrogens in the reactants is basically there's no coefficient, so you don't have to multiply anything there, and you have this subscript right here of 2, right there. That means it's going to be 2 times the hydrogen, giving you 2 hydrogens. If you remember, no subscript by our oxygen means it's just 1. So then if you go over here, our coefficient of 2 means you're going to have 2 times 1 giving you 2 potassiums, which is going to be our K. Alright, and the 2 times the F will give you 2 fluorines. Alright, let's go ahead and look to see if our products have the same thing. If you look right here, this 2 right there means you have 2 potassiums. So you go ahead and write down 2 right here. No number means you have 1 oxygen, so you'd go ahead and write that down. Then this coefficient here means you have 2 groups of that molecule. So 2 times 1 would give you 2 hydrogens. And then 2 times 1 would also give you 2 fluorines right there. So, to check to see if it's balanced, you would look to see if you have the same number of atoms of each element on your reactants versus your products, because you cannot create or destroy atoms. If y'all look there, you have 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen, 2 potassiums, 2 potassiums, 2 fluorines, 2 fluorines. So this would be balanced. Alright, let's go ahead and do the next one. And I'll go ahead and start at the top here. Our first step is to make sure we identify our reactants, I just used an R, and our products. So the reactants are always on the left, it's the first thing you start with. The products are always on the right. Now, if you're going through here counting, if you look here, there's only one, there's no number there, so it's 1, so you put a 1 right here. There is our subscript of 2. Now, once again, it only applies to our oxygen, so you'd have 2 oxygen atoms. If you look here at the P, you would have no number, which would mean you'd have 1 phosphorus. And last but not least, you would have basically that subscript of 3, which means you have 3 hydrogens, right? Oh, sorry about that. Right there. All right, let's go ahead and look at our products. All right, if you look here on our product side, if you remember, products are always what we produce, what we end with. Basically, we'll start off with our hydrogen. Look right here. We have, sorry, trying to get the arrow thing to work. There we go. All right, we have 2 hydrogens because you have that subscript. So if you look there, we put in our 2. You only have 1 oxygen because there's no number there. So you put down a 1. If you look here, we have 2 phosphorus. So if you go here, we have 2. And then last, we have this subscript for 3 for our sulfurs. So you would basically have 3 over here. All right. If you look there, basically, we're going to start looking to see if our products and our reactants have the same number of atoms. Well, if you look here, we have our reactants, we had 1 sulfur, and our products, we had 3. So that is not going to be balanced. So that one does not add up. We had 2 oxygens, and we had 1 in our products, so that is not balanced. If you look here, we had 1 phosphorus in our reactants, 2 in our products, once again, unbalanced. And our hydrogens are also unbalanced. So this would not, basically this would mean you would have had to create or destroy atoms during this reaction, which we cannot do. So it would be an unbalanced reaction, and you would mark it as unbalanced. All right, hopefully this is helpful, and you'll have a great day.